Okay, here's some how to do the 10C and 10D1 problems. All right, so 10C, sample space and events. What is the sample space for a bag of marbles containing 6 blue, 8 red, and 3 green marbles? So sample space is basically just what can you end up pulling out of the bag. So really pulling out of the bag here, we can get either blue, we could get a red, or we get a green. And that would be the sample space. So that's all you got to do is just write B, R, or G. Okay. Illustrate on a 2D grid the sample space for flipping a coin and rolling a 6-sided die. So on a flipping a coin, we can either get heads or tails. And then on rolling a 6-sided die, we can get 1, 2, 3, 4, 5, or 6. Okay. So really what we can do here is we're just going to make this little 2D grid here. And so this would be heads in 1. This would be tails in 1. Heads in 2, tails in 2, so forth and so on. So this would be our 2D grid for flipping a coin and rolling a 6-sided die. Okay. And then 7, illustrate on a tree diagram the sample space for flipping a coin and rolling a 6-sided die. So a tree diagram, we would just, oops, make this look all nicer. So we would just simply do this. We could flip the coin. So this is the coin, and we can either get heads or we can get tails, right? And then after the coin, now we're going to roll the die. So if you get heads on the first one, we can either get 1, 2, 3, 4, 5, or 6. So 1, 2, 3, 4, 5, or 6. And then same thing for this here. 1, 2, 3, 4, 5, or 6. Okay, so that would be 10C. That's the sample space and events. All right, so 10D1, theoretical probability. Look back at question 5. What's the probability of drawing a green marble from the bag? So if we look back here, we have, there's 6 blue, 8 red, and 3 green. So we've got 6 blue, 8 red, and 3 green. Okay, so probability of drawing a green marble from the bag. So there are, remember, probability is always what you want over what is possible. Okay, so in this case here, there are only 3 green marbles. That's what we want to draw out. And then the total possible would be 6 plus 8 plus 3, which would give us what, 17? So that would be 3 out of 17 would be the probability of drawing a green marble from the bag. You can just leave it as a fraction, that's totally fine. Question 5, what's the probability of drawing a green or a red marble from the bag? So there's still only 17 possible things that we can draw from the bag. The green is 3 and red there are 8, so the top is just going to be 8 plus 3, which is going to be 11 out of 17. Okay. Let's say you had 2 5-sided dice and you were to throw both of them at once. Draw a 2D grid to illustrate the sample space for simultaneous rolling of both dice. So, just like what we did on the previous one, we would do 1, 2, 3, 4, and 5, and then this way 1, 2, 3, 4, and 5, right? So then we'd have our nice little 2D grid here. This again is 1, 1, 1, and 2. And I know it says that you're throwing them both at once. I would just say, let's just call this the first die, and this is the second die. It just makes it easier to think of. At least for me, it does. Okay, so then all you do is just simply fill in all of these here, and that will end up being our 2D grid. It looks something like this. So then for part A, how many members are there in the sample space? There are 5 by 5. 5 times 5 is 25 total members in the sample space. What's the probability of rolling a sum of 6? So what we'd want to do here is just start figuring out how we could roll a 6. We could get a 1 and a 5. That will give us a 6. Let's see here. 1 and a 5. 4 and 2 would give us 6. 3 and 3 would give us 6. 4 and 2 would give us 6. And 5 and 1 would give us 6. There's 1, 2, 3, 4, 5. There are 5 out of a total possible 25, which is a fifth. Oops, let's see. Yeah, a fifth, or 0.2, or 20%. Any one of those would work. Actually, you could even leave it as 5 over 25. You don't have to simplify it. Okay. All right. Let's see. Let's take a look at what's the probability of rolling a 2 or a 3 on the first die and a 3 or 4 on the second die. So a 2 or a 3 on the first die. So what we'd want to do is just say, here's our first die. So here's where we get 2s and 3s. And then we also have to roll a 3 or a 4 on the second die. So then here's 3 and 4 on the second die. That's all of these here. And then since it says and, it's what they both have to happen. So that would be everything that's in where they both intersect here. So that would be a total of 4 out of 25. All right, and you can just leave it like that, or it's like 16% or something like that. Okay, and then last one here we have is, let me see, sorry. Just fixing some stuff here, getting a different color. All right, what's the probability of rolling at least a 2 on the first die and at least a 4 on the second? So at least a 2 on the first die. So this is going to now be in green. That's kind of hard to see. I'm going to go back and take, I'm going to redraw one of these grids to make it a little bit easier for us. Okay, so here we go. Now, with that, what's the probability of rolling at least a 2 on the first die? So remember that, again, this is the first, and this is the second. Let's make this a little easier to see. All right, so let's see, rolling at least a 2 on the first die. So at least a 2 means a 2 or more. So that would be all of these. That's 2 or more on the first die. And then at least a 4 on the second die. So at least a 4, it would be all of these here. So since it is an and, that means both of these have to happen. So that would be the intersection. So it would be these 8 out of 25. Okay. All right. Hopefully that helps on the 10C and the 10D1. If you have any other questions, please ask, and I'll help you get all figured out.